So, hello everyone. Today we will be discussing the current POTD of Leetcode. So, actually, the first and second part of the question, which are medium and hard, would both pass with the solution since it is an O of n square solution and the constraints are very low on both the questions. So, this would pass both. Okay, so let's read the questions. So we have to actually count the number of subarrays, we have to count the number of arrays which has 0 number of zeros and 1 number of ones. And also there is this one line in the question that most of us don't understand, that each subarray, so for this array, each subarray with a size greater than limit, so assume this is a window of limit size, so each subarray with a size greater than limit means limit plus 1 should have at least one of either integers. Like for example, if it's an array of zeros, if it's a subarray of zeros, so if this is of size, if there are limit plus 1 zeros, then it would be actually invalid, because for every window of greater than limit size there should be at least one present. So actually the simpler vision of this problem could be that at most we can have a limit consecutive numbers of same type. So for example, if we have, instead of having limit plus 1 zeros, if we had limit number of zeros, so this would actually be valid. But if we added another 0, this would actually be invalid, because for this subarray the limit, a window of size limit plus 1 would actually violate the condition of the question. So I'll be explaining the editorial solution of the medium problem. This is the official editorial solution of Leetcode, which uses DP to solve the problem. So we need to discuss all these things. First the state, then the transition, then the base case, then the final answer. So let's start with state. So this is actually the solution of the editorial. So I'll be explaining this. So this actually uses the states as the number of subarrays that are ending with zeros or ending with 1. So these are both types of arrays. Sorry, this one. Yeah, right. So there are some subarrays which are ending with 0 and some subarrays that are ending with 1. So we actually store the valid subarrays for both the cases. So dp of 0 actually means that we have all the subarrays which have I number of zeros and j number of ones, and those subarrays are ending with 0. And they're also satisfying the condition for the valid arrays. So just now we have discussed, right, that the valid subarrays are those which have at most limit number of consecutive elements of one type, like limit number of consecutive zeros or limit number of consecutive ones. We cannot have more than this. So now that we have discussed our state, let's move on to our transition. So now we actually have to discover the so I'll be finding out the answer for dp of 0 I comma j, and you could actually write it for dp 1 of I comma j. Okay, so now let's assume that this is an array of some size, like these are all possible arrays of some size that are ending with 0. So this is represented by dp of 0 of I comma j. So if I plus j equals to n, like if these are all possible subarrays that have a total size of n and are ending with zeros, so we actually need to consider a smaller subarray and append a 0 to it, right? So this is of size n minus 1 and we will be appending a 0 to it to consider all the cases of valid subarrays, valid arrays. So we have two substates for this. Like if we consider this one, if you consider this state which have a, so we actually know that this state has all the subarrays stored with that are ending with 1 and that are actually valid. These all are valid. So if we simply append 0 to it, that would give us our answer, right? Because if this subarray is valid, then we simply append 0 to it, then this would be actually valid also. And why is that so? Because we know that this is actually safe, and if we are appending a opposite element to this, like for 1 we are appending 0, that would not increase our risk actually, because what our risk was that we could have actually limit number of zeros or ones at most. So that does not in any way exceed our limit, and this was actually previously safe. So we simply add it to our cases. So this part is actually completed, and here is the solution for this. Now let's consider this part, because we have just considered the cases of 0, 1 something type, and this could be some sub permutation and combination of valid array. So now let's consider this case. So let's assume the limit to be 2. So we could actually have two number of consecutive zeros or ones. So let's understand what is the problem with this case. So this was the case that we considered, like this was the substate. So if we are directly appending 0 to it, like we did in the case of 1, so the problem with this is that this is actually a valid subarray, but there are two cases. So if this subarray is ending with limit number of consecutive elements, like if this is ending with 2 number of zeros, because we assume the limit to be 2, and we append 1 to it, so that actually exceeds our limit. So these are not actually valid subcases, like these are not valid cases. But if we have less than limit ending zeros, so we could actually append 0 to it, and these would be valid subcases. So how to remove this problem? This count is actually 3, which exceeds our limit. So like it is written, we need to subtract some cases to make this valid. So this was actually 2, and then we added 1 0, so it became 3, and it is invalid actually now. So dp of I minus 1 comma j is actually a valid array, so it has at most 2 consecutive zeros. So we don't even have a problem with certain kind of subarrays that are like this, that are actually ending with 1 0, like that actually have two consecutive zeros but are ending with 1 consecutive zero. So this does not create a problem because here we have at most 2. So we just need to take care of this that are ending with limit number of zeros. So actually we need to generate some permutation of these, so that we could subtract these cases from this in order to make all valid subarrays, all the valid arrays. Yeah, so here it is written that we have problem with arrays ending with 2 number of zeros, consecutive zeros. Adding another 0 exceeds the limit. So from dp of I minus 1 comma j, we need to subtract these permutations. And how do we get that? So our dp of I comma j actually had I zeros. So what if we concentrate limit plus 1 zeros at this position? So what are we left with? We are left with dp of I minus limit plus 1 zeros. So actually we have to find the good valid arrays that have I minus limit plus 1 zeros, because some zeros we have concentrated here, limit plus 1 zeros we have concentrated here. So we have to find the good subarrays, good arrays of this part. So this actually is represented by this state. So if we subtract this from the final answer, then this would actually give us all the ways that were invalid and previously added in this test case. So we added this, right? We added this to our answer, but some were valid and some were invalid. So we actually fixed this part, and then all the permutation combination of this that were valid, so we subtracted that from our answer. So we actually get our answer. So now you might wonder, why are we using dp of 1 only? Why not some array that is ending with 0, right? That is actually not, I would say, a silly doubt, but a genuine doubt. So let's consider what happened if we subtracted some kind of arrays with ending with 0. So if we subtracted this kind of array, that would actually give us 4 consecutive zeros. But we noticed that we never added something that made 4 kind of zeros, right? So actually what we added was dp of I minus 1 comma j. So we appended 0 to these kind of arrays, and these kind of arrays only had at most 2 consecutive zeros. So we had the possibility of invalid cases that have 3 consecutive zeros, right? We never had this 4th zero as our invalid case, because uh, actually this array never had 3 consecutive zeros. So this would never be an invalid case that was added. So we don't need to subtract this one, right? Now I assume that everyone has understood this part. So let's move on to our base case. Since we know that, so our dp transition depends on the I minus 1th state, or in case of dp of 1, it depends on j minus 1th state. So we would start our transition from I equals to 1 and j equals to 1. So the base case for this would be that we would take we would pre-compute the answer for the 0th state for I equals to 0 or j equals to 0. So if our arrays are ending with 0, I'm telling for this case, if our arrays are ending with zeros, and the number of zeros that are allowed are 0, so that is actually never possible, because we could not create a array with only ones that is ending with 0, right? So for these cases, that the number of ways of creating the arrays, the number of ways of arrays would be 0. And for this case, where the number of ones is actually 0, so they are ending with 0 and there are only zeros present in the array. So there is only one way of creating: place all zeros, whatever I number of zeros are there, place I zeros, and there is only one way. So for this case it would be 1. And just remember this case that we could only add only limit number of consecutive zeros. So for the value of I would actually be a max of limit, like only limit consecutive number of zeros could be added. So for these cases where the number of zeros is less than equals to limit, the number of ways of creating would be 1. Otherwise, if I is greater than limit, then it would not be a valid array, so that would be actually 0. So if you have understood the solution, just give it a like, and the notes would be provided in the editorial, or somewhere I would provide them. So that's it for today. Thank you everyone. Okay, wait, I just forgot one thing. What would be the final answer? So the final answer would be all subarrays that all valid subarrays that are ending with 0 plus all subarrays that are all valid subarrays that are ending with 1. So dp of 0 of I comma j I comma j not comma j, that would be 0 comma 1 plus dp 1 of 0 comma 1. So this would be our final answer, and that's it. Thank you everyone.